All right, class. So this is for worksheet 12.3. And what deals with is called projections. Okay. So first off, just the term how it's going to be presented. It's going to say project A onto B, which obviously in mathematics we got to condense this. It'll say project, and B's down here, and A. So notice that A is on top of B. Okay. So what we're doing here is basically B will be our new x-axis. So why is that? Well, if we work in two-dimensional, it's easy to say, well, here's our x-axis. We say this is 0 degrees, and we always build off this. But what happens if we're not we're in inner space or outer space, and we have a vector going someplace, let's say A, but we have nothing to compare to. So what we do is we pick a vector and say, well, we're going to just randomly pick something, let's say B, and B is now our new positive x-axis. So what we're going to do is build all of our components off this. So I'm going to find my x component here and my y component from B. Okay. All right, so I'm going to keep this simple to start with. So I'm actually going to start off by the x-axis so you can see how this works. Okay. So let's say we're going to project A onto B. So my A component is 3, 4, and my B component is 5, 0. Now, if we graph this out, obviously you can see that our B component already is our x-axis, but I just want to do it so you can see how this works. Okay, so if I graph out A, our A component is 3, 4. Okay, so what I want to do here is find our x component and our y component. Now you probably can see that it's going to be 3 and 4, but let me show you how it's going to work. Okay, so the first thing you got to do, step 1, is find the unit vector for B. Okay, so what is the unit vector for B? Well, since this here is 5, 0, the distance is 5, therefore the unit vector, if you divide that by 5, would be 1, 0. So that's step 1. Now, the second step then is if you dot my vector A with my unit vector B. So if I take 3, 4 and dot it with my unit vector of 1, 0, notice what we get is 3. Well, that's the magnitude of my x component. So basically, this would be my new x component of my vector A, and this is obviously a magnitude, so that would be 3. Now, if I wanted it as a component, okay, so what's my component then? Because I got my magnitude, well, notice I take my magnitude, 3 times 1, 0, and I would get 3 comma 0. And notice that would be my new x component of a, like so. Okay? And that's all you're doing. So just kind of think about if you forget the process, come back to just something simple and remember just the process. You have to have a unit vector, okay? But you have to have the unit vector of the new x-axis. And then multiply it by the dot product. But remember, the dot product always gives you a magnitude of a single value, and then convert it back into a component. Okay? Now, some of you might want to memorize notation, which I do not suggest. I always remember a process. It'll stick with you. But let me give you the notation here. So what we did here was we took A, we dot it with a unit vector B, and remember this is the new x-axis, and then we times it by the unit vector of B, like so. All right. Now, how would we get the y component? Let's come back here. Now we know the y component is this, so the y component would be 0, 4. Okay, and we know that we have the x component, which is 3, 0. So how can we do that? Well, actually, it's pretty simple. That the I want to say the a component is the sum of a parallel plus a perpendicular. Now, what is a parallel? Well, a parallel is what we just found. So let me redraw this here. So we have our a component, which is 3, 4, and our b component was 5, 0, and therefore what we found was our new x component according to A, which is 3, 0, and the magnitude was 3. Well, that is considered, when we found this new vector here, this is our A parallel, because it's parallel to our B. So this is what we just found. So we have 3, 0, and we want to find a perpendicular. And what is A? Our A was 3, 4. So basically it's just a simple algebra problem. So if we subtract, subtract 3, 0 on both sides, our A perpendicular would be 4, 0, and notice that's what we have here. This is 0, 4. We want to find the magnitude, easy done from there. Now, if you want to check, so notice that these are perpendicular here. That would mean that if I do the dot product of 0, 4 and dot it with 3, 0, notice I get 0, which means that they are perpendicular. So I can always check my math later when I'm all done to see if it works. Okay? All right, so let's go to three-dimensional now. Okay, so here's what's given. We have our A, which is 4, 3, 1, and our B is -1, 1, 2. Okay, so what we're going to do here is going to project A onto B. So that would mean that B will imply that this is our now new x-axis. So we're going to base everything off that vector. Okay? So, like for example, let's say this is Earth. Let's say Mars. And I shot off a rocket that was going this direction. When since we should be going here. Okay, so this is our new x-axis. That's the one I want to base off. So I want to find my components of A so I can learn how to readjust my direction or whatever, everything else that we've been doing for the past couple of years in terms of physics, math, things like that. So this is what we got to find here. Okay, so what's our components according to this new vector? And this new vector is now B. Okay, so step one, what's my unit vector of B? So what's my unit vector of B? We have -1, 1, 2. We got divided by the distance, so d squared equals 1 plus 1 plus 4. D equals root 6. Root 6. Now, I'm going to keep life simple. I'm not going to multiply my magnitude through like that. Okay. All right, so there's step one. Now, step two now, I'm going to dot it with A. Okay. So I'm going to take A and dot it with my unit vector B. So now remember, this is going to give me my magnitude of my new vector here, because that's what dot does. So 1 over root 6, -1, 1, 2, dot it with 4, 3, 1. So I have 1 over root 6, and what I have now is -4 plus 3 plus 2. What's that? 5, 1, so I have 1 over root 6. Okay, so that's my magnitude. So what I have now, back over here, is I have my magnitude, how long this is. So this is the magnitude of A on B. So I want my components, because I can do things with components, not with magnitudes. So take my magnitude, and think of this in simple terms. Remember to find an x component when we had A cosine of theta. Well, this is our unit vector. Okay. Well, that's our unit vector of E of B. So here's my magnitude. Multiply your magnitude by your angle, and you have it. So it's the same thing as A cosine theta, your last step. So, in other words, I'm back here for step 3. So I have my magnitude, 1 over 8, and I said think of, now this is your unit vector. My unit vector for B is, I get another 1 over root 6, and -1, 1, 2. So simplifying this, so my new x component of A, which is now on B here, is 1/6, -1, 1, 2. And that would be A parallel. Okay. So if I want to find now my y component, okay, so my components for A is A perpendicular plus A parallel. Okay, so my A component was 4, 3, 1. My A perpendicular is what I want to find, and A parallel is 1/6, -1, 1, 2, and therefore all I have to do is subtract here, and I'm going to have to distribute through here. So negative 1, 6, 1, 6, 2, 6, and that would be a perpendicular, whatever that is. And I don't know if I've done that or not. No. So I'm going to let you do that. Plug it in a calculator, let's put it that way. Okay, I'll do another one here in a second. All right, so that's what we're doing here. So let's do another example. And then I'll actually do the math of this last one. I just don't have it written down. So let's start a whole new example. Okay, so we have vector A, negative 2, 1, 3, B, negative 2, 2, 1. So let's find, like say, A parallel, which is the same thing as project A onto B. Okay, and we'll go ahead and find A parallel. Maybe we'll see. All right. So let's start off. Let's do this piece first. All right. So visualize what we're doing here. Okay. Here's our B. Here's our new x-axis. Okay. We have A, so we want to project that on here. So the first thing we're going to do is actually be finding the magnitude of A. And actually it should be like this. So we got to find the components of B. Excuse me, the unit vector of B. So the unit vector of B would be negative 2, 2, 1, divided by, let's see, B squared, excuse me, D squared, 4 plus 4 plus 1. So D would be root 17. Excuse me, can't add. Root 9, which is 3. So it'd be 3. So unit vector B would be 1/3 of negative 2, 2, 1. All right, so that's a unit vector that we can go by. So again, visualize this in two-dimensional. My x component would be A cosine of theta. That's what we found right there. That's our unit vector. Okay, so let's go ahead, multiply it by the magnitude. So step 2, so I'm going to take A times by EB. So I'm going to have, what's my negative 2, 1, 3, times it by 1/3, negative 2, 2, 1. So I have 1/3, and I have 4 plus 2 plus 3. So we got 6, 9, 3, is it? And that's our magnitude, and that would be the magnitude of our new x value. Okay. So basically, we found our new x component of A. But remember, this is the magnitude. So, but we need components. So therefore, step 3, take 3 and multiply it by the unit vector, which is 1/3, negative 2, 2, 1. And what we have now is A parallel, which is negative 2, 2, 1. Okay. All right. And now let's go ahead and find the x component. So again, remember this is the x component of A. So we have A component, it equals A parallel plus A perpendicular. So my A component, what was it? was negative 2, 1, 3. A parallel would be negative 2, 2, 1. And A perpendicular is what we need to find. So again, just subtract out. So that would be 2, negative 1. I already multiplied by the negative, by the way. So A perpendicular, that would give me 0, negative 1, negative 2. Okay, so what did I just find? Well, I found my y component of A, which is referred to on B. Okay, and if I want to just double check, geez, did I do all this right? Let's just go ahead and if we do A perpendicular times, or dot, A parallel, I should get 0. So I have 0, negative 1, negative 2, dot it with negative 2, 2, 1. So we have here 0, minus 2, did I write something down wrong here? Yep, there's, that should be plus 2. There's my mistake right there. So this should be plus 2, and plus 2, and therefore it's 0. So it checks. Okay, so I got my two components. All right. Hopefully that gives you enough information there. I'll do another video after this one just to see if it's making sense and add maybe one little bit more to this. So